the data up, right?
Yes.
Okay. So I'm going to walk you through, this is an SPSS window. I'm going to assume you haven't had very much orientation to this program. Is that thumbs up correct?
Yeah, that's correct.
Okay. So the basic SPSS program has two tabs that you can toggle back and forth between. One's the data view and the other is the variable view. The data view shows you the list of participants. So these are random numbers that were generated for the participants in this study, the first column, and then their scores on everything that they were assigned scores on, or the numeric version of the observations. They probably were just checking a box that said male or female on this, but it was coded 1 or 2 because you can't do statistical analyses on words. So all of these things will have numbers in them unless you've left room for people to do. So I'll get sheets that have, you can put words in, and I'll get sheets that have people write their undergraduate majors. I'll have sheets where they provide their email address so I can interview them later, all kinds of different things like that. But these are all just numbers. So this is the data view. It's the numbers that you have for these are cases, and these are observations. The variable view names your variables. So the first one, that random number, is the respondent ID. And you see that up at the top. And we don't have to say anything about it. The second one is gender. And the interesting thing that you can do in this variable view is that there's this value area where you can write down what those numbers mean. So in the data, you might have noticed that everybody is either a 1 or a 2. So under variable view, we've actually explained, and this is optional to explain what they mean, but it's very useful. We have explained that 1 means female and 2 means male. So when we're analyzing the data, we don't have to remember, oh, 2 equals male, because it'll pop up in the results. And so we know what, if you look at data view for high ed, there's values 1 through, 5 or 6. Just looking at it, or if I reported it as numbers, I would have no idea what those mean, because they're really categorical variables, right? They're really categorical variables. And so they have to mean something besides a number. But I would know unless I had put in this kind of little code, which tells me that a 1 means high school, a 2, etc. And the question was, what's the highest degree you've obtained? So I have that for a bunch of the variables. Are you a full-time teacher? My variables, I try to name things as things that make sense. I don't really like to fill in this column. You could use to fill in what you mean by that name, but I try to avoid it just because it fills up various places that are confusing. So this means, are they a certified? I know this data, right? These are my data. As a matter of fact, I've kind of probably fudged them considerably for this class, but I still know what they mean. The VEL, if you look at, these are all teacher candidates, I believe, but some of them are also full-time teachers. And so this is the area in which they're getting their certification. And that's what's called DEV, because the primary categories are developmental level. And we just kind of left it there. It's not really a name, DEV, that makes sense, but that's the way it is. Age is, we were talking about age last class. So this is just a numerical variable where they wrote in their age. no ranges. And these are the things we measured them on. So this, you see these pre's and posts. So it's a pre-post study. And this is the experimental manipulation. So now I'm remembering this thing. This is an experimental manipulation. And I told you about this because this was the study where I tried within an online study to randomly assign people to 3 different conditions of like 3 different types of surveys. And I gave them this picture that they were supposed to think about that was their type, what the condition was that they were assigned to. Were they like students with behavior problems? I don't remember what it was, but something like that, different types of students. And then I asked them what group they'd been assigned to, and they all got it wrong. So I guess this is just condensed into the people who got it right. So some people, they're actually just 2 groups. I guess these are, they were assigned to students. They were assigned to think about classrooms where the students were at low performance levels, or think about classrooms where students were at high performance levels. They were randomly assigned to one of those 2 categories. And the people who are in this data sheet are people who paid attention to the group they were assigned to. So they're kind of verified people. So pre-test, then they were assigned to think about something in particular, and then post-test. And these things were just administered once. I'm going to use this example later to talk about like experimental design and, you know, using this random assignment and pre-post designs and how you analyze them. So we're not concerned with those right now, but I wanted to show you, you know, what is this data set about, kind of. They're people in different programs in the School of Education here. We asked for gender information, what their highest degree was, whether they were a full-time teacher, and whether or not they were a certified teacher. Then we administered them a pre-test. Then we asked them to think about a certain group of students. And we administered a post-test and a bunch of other stuff. Got it? Got it?
Yes.
Got it.
Okay, so now we're at the level of sampling. So I got these people from our research participation pool in the School of Education, which means that they were all people in some kind of course in human development. And they were all pursuing some kind of teaching certification. Or what do they call those things? Credential. And so the population that I was interested in generalizing to were people in teacher education who were pursuing certification in any of these groups. Did I have a random sample?
Convenient sample.
I had a convenient sample. Okay, so here's my sample section. Here's my participant section. We, Professor Chen and I, collected a convenience sample, what's the next thing you see usually in parentheses right after that?
N equals.
N equals. So now I need to know how many people do I have in the sample? So what I'm going to do is I'm going to, and this is kind of a wacky way of getting the sample size, but I always tell like all of my RAs, never scroll to the bottom of the data or scroll through the data and say what anything is. Because it's a technique that doesn't work when you have 9,000 or 90,020 people. You just don't want to do all that scrolling. So there are other things that work better than that. So I'm just going to find out what the average respondent ID of the sample is. Meaningless statistic, totally meaningless, but it will give me, oh, look, SPSS has a power analysis in it now. Okay, we'll come back to that. It didn't used to, and my version of it doesn't. So, but my version doesn't function. So this is how you start doing analyses in SPSS, is you have this menu, and many of the things are just like any other menu you're going to see. File, new, open, save, save as, edit, undo, cut, copy. It's got a lot of other stuff on it. View, what do you see? But where you start to get things that are interesting are under data, transform, and analyze, and graphs. So data has a ton of really cool stuff that you can use a lot. Like you can select cases that have certain characteristics. Like I could select and do all my analyses on just the women. I tend to use that one a lot. There's merging files, which is a huge hassle, but if you gathered your data 1 year and then you gathered it another, then you might have 2 separate data files and you have to merge them. Transform is changing something, like taking 2 variables and adding them together, or subtracting one from the other. You often do this with, if you want to like calculate growth, like you had a pretest and a post-test, and you want to see if the pretest is smaller than the post-test, or the post-test is smaller than is bigger than the pretest. You just create a new variable that subtracts one from the other. And we actually have that in this data set. When it says man difference, that's post-test minus pretest using this transform thing. I computed the variable, manage, I have to call it something different here, difference, by saying, can you see that where yeah, you can see everything I'm doing. Where I just did post-test minus pre-test. And then you'll see you get this new variable. So that's what you can do, one of the things you can do under this, but we're going to go live under the analyze menu when we want, what we're going to be wanting to do here is describe things, because we're talking about the sample. So in our participant section, we now have, we gathered a convenient sample of, or we gathered a convenient sample, parentheses, n equals, and we're just really stupidly going to say, hey, I want to know how many people I have in this. And I know everybody, you can't do this with just any variable because some people may have left it blank, but I know everybody has an ID. And so this is, I'm not going to spend time with you on this particular descriptive because we're just using it to get the sample size, but I'll come right back to this in a minute. So 194. We know we don't care about any of these things because they're just nonsense numbers, the IDs, but we know now that we have descriptive statistics for the respondent ID respondent ID. There are a possible valid N of 194, and we have 194 responses. So we have a N equals 194, close parentheses. We collected a convenient sample, N equals 194, of pre-service teachers at a public school of education in a densely populated urban area in the United States. Now, what else, not even bothering to look at this, what else would somebody want to know about this sample?
I see something like a classroom thing right now. I'm not sure what.
I did it so that I would take you, it's nothing, it's nonsense. I just want, so you weren't looking at the data field, so you could tell me, what do I want to know? We collected a convenient sample, N equals 194, of pre-service teachers in a school of education in a public university in a densely populated urban area in the United States. I've got that. That gives you my sample size, my method of sampling, and my population. Now, what else do I want to tell you about my sample in my participant section?
You might want to know different demographic breakdowns like male, female, or like area of specialization.
Maybe.
Are they ed or are they secondary, something like that?
Yeah. Did you say they were all from the same institution?
Yes, that's just a characteristic. So I don't have that as a variable because it's true for everyone. They're all from Hunter College. But you don't say Hunter College, you don't say CUNY, you don't even say New York City usually, because you want, that's usually mostly for confidentiality reasons. So, okay, so I think that was Natalie says that you might want to know some demographic things. So.
No, Rebecca.
Oh, Rebecca, I'm sorry, I can't usually tell who's talking. Or it's, you know how it is with Zoom. It's all that back and forth looking.
It's okay. Just wanted to give her credit.
Thank you. So now with demographic things, you know that you have different kinds of levels of measurement, and the same kinds of analyses are not used for every single kind of one. So what level of measurement, what kind of variable is gender? In the way I've measured it, which is I've got female and male.
Ordinal or
Nominal.
Nominal.
nominal?
Nominal, okay? If it were ordinal, it would mean that one was bigger or better than the other. Not gonna go there. So I'm not gonna even think about that possible conjecture. So, so it's a nominal or categorical variable. How about higher education? That is, what is your highest level of education given these choices?
I mean, that's ordinal, right? Like, because it's more time spent in school. So
Yeah. Yes, it is ordinal. Yes, it's ordinal. How about, are you a full-time teacher? Yes or no?
Nominal? No.
Yep, nominal. Are you Do you have certification?
Nominal.
And what is your program in the School of Education?
Nominal.
Nominal. Age?
Not ordinal, but
Is that interval?
Do we want to do a hand vote? Or do we just want to, someone answer the question, is it, we've heard, okay, so it sounded like there was, someone said it's above ordinal. Is it interval? Are there equal increments between?
yeah.
Yeah, it's interval, and in fact, it's a ratio variable, but we don't really care. Once we get to interval in social science statistics, then we don't really worry too much about whether it's ratio or interval most of the time. So actually, I have already, there is a thing in SPSS where you can categorize the level of measurement. You tell SPSS what it is, and anything above ordinal, they just call a scale. You don't even distinguish between interval and ratio in SPSS. And these will be decided for you, like it thinks that respondent ID is a scale variable, which it isn't. The magnitude of the numbers are meaningless, but it'll assign things by default, and sometimes it's wrong about them. So I've gone in and fixed all of them except that one, which I'm now fixed. Okay, so those are our demographics that we know about. So which of these can we take an average of?
Age.
Any other?
Well, I mean, you can take an average of, say, something like, say, the number of years in school, but you just have to take into account, like, the fact that it's not an interval, right? Like, you can't say that all of them are equivalent, but you could say that, say, the median is someone who had like a college degree versus a master's degree or something. Like, couldn't you do like maybe not a mean, but a different kind of average? Could mean like a mode or something.
A mode. You can do a mode. So you can't do a median or a mean on this because we've coded them as 1 through 6. We didn't write down 12 years or fewer, 14 years or fewer, 16 years or fewer. You know, we didn't do it like that. So they're not really numbers. They're not being treated like numbers. You're absolutely right. It is an ordinal scale. It has numbers associated with it, or it has magnitude associated with it. But it's kind of like we've rendered it into, just by the way we've asked people to report it, we've rendered it into essentially a nominal thing. And so the best we can really do is report the mode. Although there's some additional things that you can report as you wish within this. So also with our binary variables, we're going to just report the mode or the percent in each. So age is the only one we can calculate a mean for. So I might as well do that first. To calculate a mean in SPSS, you use the analyze. That's where basically all of your analyses are. And you go to descriptive statistics. We're describing our participants. And you want descriptives. When you want like modes, then you want frequencies. When you want descriptives, like means, you want descriptives. However, I just thought of a little complexity, but I want to do it anyway. Under frequencies, you can also get means, and the frequencies options are better than the descriptives options. So I always get my means and standard deviations under the frequencies options. I could go into a little digression about why SPSS is very redundant. You can get means and standard deviations under frequencies, descriptives, explore. You can get them under compare means. You can get them under the general linear model. They're so correlate, regression, you can get them under a lot of places. And so there's a lot of redundancy in this program, which isn't always a bad thing. But we're gonna get age through frequencies. And in fact, that's the only descriptives menu we're gonna use. So we're gonna ask for age, and we are going to ask under statistics for, so these are, so you say, analyze, descriptive statistics, frequencies, and then it shows you the menu of all your variables. And it's like, well, what am I interested in? I'm interested in age. And then you have all these different things, starting with what statistics do you want to know about age? So you have all these choices. I want to know central tendency. Remember that term, central tendency? You haven't heard that since week 2, week 1 of your class. I want the mean and the median. And I want the standard deviation. And this is age, I might want the minimum and the maximum. So I tell it to continue. I happen to want to know, just because I'm teaching something, a couple of other things. Mostly what I want to know is I want to see the histogram. I want to know what the distribution looks like. And what I don't want is the frequency table, because that will tell me how you've made frequencies tables in stats class. They tell you what % of time does each individual score happen. And I don't want to know that 1% of the sample is 21. It's not interesting to me. So I frequently forget to uncheck this, but I don't want to see that. I want to see the mean, the median, the standard deviation, the minimum, the maximum, and the histogram. You know, up here, it tells you in what they call syntax, what you've asked for. You've asked for the variable of age, standard deviation, minimum, maximum, mean, median, and the histogram. So you have 3 people who left out age. You have to report that in your participants thing. So you're going to say the mean age was 26.6, parentheses, n equals 191. Or you could just say with 3 missing cases. There's your medium, and you will always say what the standard deviation is. There are a lot of different ways of articulating this. Sometimes I'll say, you know, the mean was 26.6. Usually you'll just put in parentheses SD equals 7.4. But you could say, you know, the average person was in their mid-20s. Parentheses M equals 26.6. SD, comma, SD equals 7.41, or 7.4. there are multiple ways to say it. You want to always give, whenever you report a mean, report the standard deviation. And if there are missing cases, report if there are missing cases. Some people just didn't want to say what their age was. And then what can you tell me from this histogram?
That the data skewed.
What kind of skew?
Oh, I always get this wrong.
I
Right?
do too, or I used to until I started teaching it.
Is it right skewed or no?
Yes, no, it's right skewed. I call it positive skewed. I guess Professor Chen calls it right skewed. It's a skew is characterized by the outliers, by the tail of the skew, whichever direction it's in. It's not characterized by the clump, it's characterized by the outliers, because that's what makes it skew. So this has a positive skew or a right skew, meaning that the bulk of people are between 20 and 30, with a few, particularly one person who, when you get the minimum, the maximum, you see that there's one person who's 62 years old. You can put that in writing. I mean, it is actually, when you have something that's this skewed, it's kind of, your audience should know it. You know, so you now said, we did a convenience sample, blah, 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 people at this place. The average age was 26 and a half. I think saying something like 26.6 for age is kind of weird, but most people would say 26.6, parentheses SD equals 7.41. The maybe semicolon period, the data were positively skewed. Most of the respondents were between 20 and 30, but there was one participant who was 62 years old, period. Okay.
I have a question, not about age, but gender.
Yeah.
So, I don't know, for teachers specifically, we know that the majority is female.
Yep.
Now, for the proposal, because we don't know, like if we had already done this and we were reporting what we had done, then we would say, you know, there's this many females, this many males. But when we are proposing, should we be proposing to have 50-50 or?
Not unless, yeah, that's a really good question. Not unless there was a particular reason that you wanted a balanced sample. And you probably wouldn't. So what you could say in your proposal is that your participants were or are expected to be predominantly female, as typical of the really the US population of teachers. And someplace on these slides, I have, and I don't know if I'll get to it tonight. I never get to anything. Oh yeah, I actually have this. You can go to the National Center for Education Statistics and get all kinds of things about teachers to see, like, what should you expect? And here I got the age, which I'll show you why in a minute. But the it'll probably tell you what the proportion of women in New York City, or yeah, it might tell you in New York schools what the proportion of women is, in which case you could say, this is what I expect. You don't have to go in here, but you definitely could. And sometimes the reason I have this example in here at all is because this is a way of testing whether or not the sample that you get is representative of the expected sample. which I'll come back to in a minute.
Thank you.
Yeah, so I would, short version is propose that you're going to get what you would expect to get. Okay, so with back as Sorlin's, that was Sorlin, right?
Yes.
As your question led us. So now we've got our descriptives on age, and now we want our descriptives on the other demographic variables, all of which were categorical or nominal. So I'm going to take all of those. You can do it, just like you would do it with other things. You can hold down on shift and get the whole cluster. You can hold control and select one at a time, or you can just select one at a time. And I'm going to bring those over. Can you still see the SPSS screen?
Yeah.
Yes.
Okay. So I've got those, and I'm not actually going to ask for any statistics on them. I could ask for mode, but I don't really need it because I'm going to get the frequency tables and I'm going to be able to see the mode, as you'll see when I bring it up. So I'm just going to say, okay. And this just tells me if I'm missing any cases. So certification level, I'm missing 125 cases. And that looks really weird to me. Like 4 people who didn't answer, are you a full-time teacher? That's not a big surprise. But 125, so what's going on with that certification question? So when you see something weird, you always go back and look. And with the certification question, there's all those little dots, that means missing data. I remember, otherwise I would have remembered anyway. But when you look at these data, just looking, I tell people don't, but if this were your data, you'd know it. Now I remember it. So do you see any pattern between the people who have non-missing data to certification and any other information in here? Yeah.
The full-time teacher?
Very good. Okay. I'd completely forgotten this. The only people, it was like a logic question in an online survey, is the only people who were eligible to receive the question, are you a full-time teacher or are you certified, were the people who said, yes, I'm a full-time teacher. So that's why it's the way it is. Okay, so that's why that's that way. Let's go on to the more, all right. So really good that I looked into that because I couldn't remember. All right, so this just tells you how many cases had answers. Gender, it will always tell you both the percent out of 100, right? Your bottom percent on a frequency table should be 100, but it will also tell you the percent among only those people who answered. So since one person left this out, these values are very slightly different. And what I usually report is I report the valid percent, and then I'll also say how many people. So I would say something like 81% of the sample were female with 1 case missing. And that's really the most information we have here about gender. And you don't need to bother to say 19% were male, because if you've only asked those 2 categories, you might say people were only asked if they were male or female with no other space to answer. In terms of highest degree of education, what's the modal category?
What's the question?
What's the modal category for highest level of education? What's the mode?
It's hard to read, but BA.
Yes. So 62% of participants had completed a bachelor's degree. You might say, so the cumulative percent tells you that what would be actually, it would be more interesting to know really the 62%. So actually, no, it is. So is there anything else that's interesting in here? Having to do with the cumulative percent? Not really. Can anybody else see anything interesting in this? I mean, there's kind of a large percent who had only completed a high school degree. Those are the undergraduates. Does anybody see anything interesting in this that they want to comment on?
I mean, I would be curious for the 11 who completed associates, did they also complete their BA?
This is the question. Now, they may have misunderstood the question, but the question, which you can't see, asks them, what is the highest degree that you have completed?
Completed, right.
So if they also completed their BA, they should have clicked BA.
Mm.
And sometimes people will make mistakes about that. They'll think, like, what level of education are you currently in, instead of what did you already complete? So people will sometimes assign themselves the wrong category. And that's kind of no matter what you do, people will sometimes assign themselves the wrong category. So most of them were not full-time teachers. And now we're going to have to break down this thing. But these are the percents of people at different developmental levels. I want to go.
I have a question.
Yes.
What's the difference between percent and valid percent?
Valid percent is using as the denominator for the percent only the total people who actually answered.
Oh, okay.
These percents here, these are 69 out of 194. 121 out of 194. The valid percent is 69 out of 190
Okay.
who actually answered.
Okay, thank you.
Use the valid percent, but then always also state 4 people didn't provide answers. So now I can just put this in my narrative. I can say the stuff that I said about age, and then I could say, and the level of precision here is kind of up to you. Sometimes you want to be quite precise and sometimes you don't. But I might very well say in the narrative that the majority of participants were female, parentheses 81%, as would be expected in the teaching profession. And maybe a citation, or maybe I wouldn't have say as would be expected. And so the majority of participants were female, parentheses 81%, and had completed a bachelor's degree, parentheses 62%. Okay, now I can just make it all in one sentence. The majority were female, 80%, had completed a bachelor's degree, 62%, and were full-time or were not full-time teachers, parentheses, 62%. That would be the end of that sentence, because I have to be a little bit more specific about this certification level, because this is of the people who are full-time teachers. So you could just say of the people who are full-time teachers who said yes to this question, only of the people, that's where your valid percent comes in. See how different these numbers are? So not of the 194 people, but of the 69 who answered this question, 39% were certified. Okay, so majority female, had earned a bachelor's degree, and were not full-time teachers, with all the percents in parentheses. Of the 69 participants who were full-time teachers, 27 were certified, parentheses, 39%. And then the only thing you have to add to your narrative about your participants is this distribution. You could say something, well, probably, I don't know whether some people would just add an extra sentence saying 34% were in childhood education, 30%. Some people would say the participants were fairly evenly distributed among childhood, adolescent, and special education programs. Some people would have not said very much of this at all and say, see table 1 for participant demographics. Like after age, they would have said, see table 1. So I'm going to show you an example of such a table. So this is like slightly different data, but characteristics of participants. This has age ranges, like we were talking about in class last time. It has, this is not, that formatting probably, I don't know where that got screwed up, but it has the number. You have your, if the overall sample size, you can often put in the title of the table number, and then the number and the percent, and note it says here valid percent, and it tells you the number who are missing from each category. And these two things were ranges. In which case, the one thing you don't want to be is redundant. If you're going to put stuff like this, and you're not going to use, obviously, a table, I would say that for your proposal, what you should say is basically, what's your population? What sample size are you going to try to get? You can use GPower for that if you want. And I will demonstrate for you, probably on a video, because they won't let me download it here. So I can't do it in class, but how to get a sample size estimate, and any characteristics that you can anticipate would be most common. So, you know, the majority would be expected to be female and certified in such and such an area or whatever. Or if you're going to, many of you are restricting to a certain group, right? So all participants were first generation college students or whatever. Okay, you don't have to, this is for your general information for how you would do these things in future research. Okay, oh, I hate that. Oh, okay, so one thing that you might want to do is find out something about your how well your sample represents the do I want to do this? Bonner's thinking. Bonner's thinking. Why did I want to do this? No, I don't want to do this. Yeah, this is some stuff about if you wanted to know, and these are things that you have learned to do in your stats class. So it's 9:20. I don't think this is worth it, but again, I might make a teeny tiny video. If you wanted to know whether or not your mean in your sample was comparable to a national statistic, you could you'd really want to use the one sample t-test. So you could test that fairly easily. Okay, we can test this right now. Bonner can never resist these things. Okay, so the population, New York City average age of teachers is 42.5, according to the federal government. So we have these people, let's pretend that they're teachers. Let's just pretend that they're teachers for the sake of doing this test. Okay, all of these people are full-time teachers. And we want to know, are these people representative? Do they fit into the population of teachers in New York within the range of sampling error? Is there a representative sample in terms of age to the teachers in New York? So we're going to do a one sample t-test. We have our sample, we know our sample mean for age, and we know our sample standard deviation for age, and we know the population mean from the Center for Educational Statistics. So that's enough to do a one sample t-test where you're comparing a sample mean to a population mean, but you don't know the population standard deviation. So we have our share screen. I keep getting insecure about what you can see. Here is our population age, 42.5. Don't let me forget that number. It doesn't have, the center does not give you the population standard deviation, but we have in our data everybody's age, so we can take the mean and we can get the standard deviation. So we're going to run a one sample t-test to find out whether or not the age of our group is comparable to, this is where a test value comes in, 42.5. So we're testing our sample age, using our sample standard deviation in the error term against the population age for New York State for teachers. And that tells you that the magnitude of the t statistic is 29.6. This is like the biggest T that you will ever see. Okay, you're not really supposed to talk about how big the effect is. Well, you can talk about how big, or you're not supposed to talk about how significant some, but on average, the difference between the our group and the population group is 16 years younger. Okay, so our group is on average way younger than the New York City population of teachers. So it's something you might want to do. You might want to say, hey, my sample was not representative of New York City teachers. It was much younger.
But isn't it all pre-service teachers that you're?
Yeah, my actual sample is pre-service teachers. I was putting in like, yes, with this sample, we're not surprised. But I was saying, like, if you had just teachers and you wanted to compare them, I can't, I don't have statistics on pre-service teachers. So that's probably, I have one thing here about if you wanted to describe more than one characteristic at once, which is nice, but we don't have to do that because it's 9:27 and we did